In this lesson, we're going to introduce the frame generator. The frame generator is going to be based on the principle of skeletal modeling, which in case means that we're going to base our frame on another part. So we're going to start off by creating that skeletal part. From the new icon and from the English tab, I'm going to create a standard inch.ipt file. And let's place in a rectangle. And I'm going to place a couple dimensions on that. So let's call it 25 by 20. I'm going to change to an isometric view. And let's extrude that out 30 inches. So what I'm going to do at this point is I'm going to orient my screen so I'm looking at the XY is actually going to be on the bottom plane. Because what I want to do for our assembly here is I want to have a cross member going right across the middle portion of this. What I'm going to do is I'm going to place in a sketch, and then I'm just going to place in a line segment that will go from the middle of the two line segments. And that's all I want to do for my skeletal part here. So we'll exit out of the sketch. And into the Chapter 9 folder, let's just type in skeletal. Go ahead and save that. I'm going to start up a new assembly file. Again, from the English tab, I'm going to click on Standard Inch IAM. And then I want to place in our skeletal part that we just created. And now what we're going to do is we're going to use this skeletal part to base our frame members on. So I'm just again going to orient my screen so I'm looking at the front face here. And what we're going to do next, from the assembly panel, select on Frame Generator. As you can see, our tool set has changed, and we'll run through a lot of these in this lesson. I'm going to start off by inserting. As you see, when I clicked on Insert, Inventor is alerting me to the fact that I should save the part. So I'll just type in a name. Now from the Insert dialog box, what I want to do now is select the standard that I want to work with. In this case, I want to base it on ANSI. The type from the list, you can select the standard components that you want to go back and create. In this case, I'm going to keep the square tube as my default. The size, again, just from the list, go ahead and select it. And I'm going to go back down here and let's place it in by 3 by 3 by 16. The material, I'll go with steel. The color, I'm going to keep the default. And for the orientation, I have them representing the center of the tube, but you can go back and designate the starting points of them as well. So what I want to do now is start selecting my edges. So I'm going to go ahead and do that. I'm just going to select my 4 vertical lines first. And then I'm going to work my way around, selecting the top edges. And lastly, what I want to do is I want to select that cross member line. So as you can see here, Inventor allows us to go back and utilize edges and points. If you're in assembly, we can project edges forward to go back and help define where are those frame members going to be placed. So let's go ahead and click on OK. You can now designate a subassembly name. In this case, I'm just going to keep the default frame 001. You can define its location. Again, I'm just going to take all the defaults. So now that my frame has been generated, I probably don't need to see that skeletal part anymore. So I'm going to turn its visibility off. So now I can get a closer look at what my assembly looks like here. As you can see, all of my tubes at this point are going in towards each other. So let's go back and start to clean them up. And the first tool we're going to take a look at is going to be Miter. And Miter is a very easy tool to work with. I'm just going to start selecting 2 components, and I'm going to apply to bring them back together here. So if I pan this over, you can see exactly what it's done. Also in this dialog box, you can go back and designate if you want to have a gap in between them. In this case, I'm going to have them touching. So there's going to be 0 for the gap. And we'll just work our way around for these last couple. So those are all the miters I want to do. I'm going to go ahead and cancel out of that tool right now. And let's take a look at trim to frame. So trim to frame, I'm just going to select the two components on the left-hand side here, click OK. And you can see what Inventor did is it went back and it trimmed and extended those frames off. Probably not what I want in this case, so I'm going to undo that. And let's take a look at trim to extend a face. So what I'm going to do now is I'm going to select the component that's going to be trimmed, and then I'm going to select the face that it will be trimmed to. As you can see, I'm clicking the Apply button, which allows me to maintain the tool. Don't have to restart it. So I'm just going to work and do the exact same scenario. Select the face to trim back to. And now what I'm going to do is I'm going to use the same tool to go back and trim back these 4 vertical faces. For the frame member, what I'm going to do is I'm going to select all 4 vertical pieces of tube. And then for the face, spin the model around. Select the bottom plane. In this case, it didn't matter which one I selected, since they're all planar to each other. Let's cancel out of that. And as you can see, our frame is definitely taking shape. But what I want to do now is, let's say I want to change out this cross member. I don't want that to be 3 by 3 any longer. I want that to be rectangular tube. So before I change that out, let's take a look at the browser. So if I expand on that component in the browser here, you'll see that I have some end treatments. Those were the ones that we just placed, the trim and extend. So keep that in mind here as we go back. I'm going to go back and switch out this component. We want those end treatments to be maintained. So what I'm going to do now is just go ahead and click on Change. And then I'm going to select on the cross member that I want to switch out. Again, we'll keep the ANSI standard and the type. What we'll switch this out to in this case will be a rectangular tube. And let's change the size to 4 by 3. So we'll slide down a little. 4 by 3 by 3/16. Now let's rotate the screen here a little bit so we can see exactly what's happening here. So again, if I go back and start to select on different options with the orientation, you'll see that the tube is moving to reflect that new position. So in this case, I'm also going to change it right back to where it was with the center. You can go back and rotate this if you were inclined to do so. So if I change that to 90, you can see that the tube has been oriented. Or let's change that back to 0. Exactly what you're seeing is what you're going to get here. So let's change that again back to 90. Probably was the best way to have that. And let's go ahead and click OK. Inventor is telling me that some changes have occurred and the end treatments. And we'll go ahead and we'll click OK. So again, let's spin the model around. And you'll see that the tube has definitely been trimmed. If I scroll down in the browser again, you'll notice that the end treatments still exist. So Inventor maintained those. So for our last scenario here, let's go back and I want to make a change. So let's say the design has changed. I want to go back to my skeletal model and I want to make some dramatic changes. So let's go back for the extrusion and let's make it twice as long. So I want that 25 to become 50. Let's make that 20, 30. Let's return. I'm going to edit the extrusion. So right now it's at 30. Let's change that to 60. You'll see that the line representing our cross member is still right in the middle. So I'll go ahead and save this part. And then we'll change back to our assembly. Click on Update. Pan back a little bit here, and you'll see that Inventor has updated all of the frame members to match all of the edges that were altered in our last edit that we have done.